shortcut in here, and it's going to launch the application for us. So as you load a Libre design, you will see that our CAM plugin is automatically installed and loaded, so once it's installed on the computer. So if you go over to the Add-ons tab, you'll see that AlibreCAM menu shows up right in here. You click on it, and you can choose mill for programming 2 to 5 axis indexed machining, and we have turn for 2 axis CNC lathe or turning center programming. So you'll now notice that it says units not supported, so you need to be either in English or metric units. So you can go back into your design, go to properties, and make sure that the units that you're going to be working on, so it says it's centimeters. Would you prefer inches or millimeters?
You can do either. Inches probably be easier.
Okay. So we'll do inches, and then we'll apply it. And now if I go back and load the AlibreCAM module, you'll see that it automatically loads. And there's your CAM interface. You can go back to Design Explorer, AlibreCAM. You just have to go ahead and resize the browser window so you can see all of the controls in the AlibreCAM's ribbon interface. Now, the configuration, what I'm running is the Pro configuration of AlibreCAM. We have Express, Standard, Expert, and Professional. The Professional is our top of the line, which offers all the way up to indexed or positional 5-axis. We can also do advanced 3D milling and 4-axis. Now, this particular part that you have in here, you could use our standard configuration to very efficiently program it. And the workflow typically would be the first step is once you have the part loaded and the AlibreCAM plugin loaded, you just have to make sure that you orient the coordinate system for machining. So by default, it orients in the same orientation or uses the same orientation as your world coordinate system in Alibre, which means in this particular case, your z-axis is normal to this particular surface. But by looking at this part, it looks like most of the features that you have can be flipped over and machined because you also have this slot in here, right?
Yes.
Okay. So the way I would orient the coordinate system is just go into the Program tab in AlibreCAM's machining browser, and then you select Machine, and this displays Machine Tool Setup, and under the Machine Tool Coordinate System Setup, you can orient the coordinate system in here. With the standard configuration, you can have one orientation per part. So if this part requires some machining from multiple orientations, you'd have to save this as Part 1, Side 1, Part 1, Side 2, so you can establish different coordinate systems on each of the parts. In our Pro, we can have more than one coordinate system defined for each part, more than one coordinate system orientation defined for each part. So in this particular step, I could choose to rotate it. I can rotate it on the X or the Y by 180. So I can do 90 times 2 is basically 180, and then I can also establish the orientation for the X and the Y. So currently the X-axis, which is the green arrow, is parallel to this edge, and then the Y-axis is parallel to this edge. So if you prefer the X to be parallel to the longer edge, you can also rotate it in here. I can rotate about the Z-axis. So now the X-axis is parallel to the longer edge as compared to the Y. And now I can pick OK to accept it. So you'll now notice that the coordinate system is oriented. So this is the world coordinate system, and this is the rotated coordinate system for machining. So as you look at it down from the top view, your X-axis is parallel to the length of the piece, and then the Y is parallel to the width. Any questions so far?
No.
And the next step is select the post processor in here. We do have a post for a TAG. We can select the post processor from the list. And all of these posts are included with the product. And you can also custom edit the post if you need to make any changes to it. We can help you modify the post, or you can do it by yourself as well.
Okay.
And you can choose the extension. Could be NC or any preferred extension for your machine tool. In the next step, you'd want to establish the workpiece, the stock material. So you choose stock. With the standard, you have access to box and cylinder stocks. So as you pick box stock, the system will automatically compute the minimum extents, minimum stock size that you need to be able to efficiently program this part.
Okay.
So it gives you a length, width, and height. And in this particular case, it's just short of 5 inches in length and 3 inches in width. So if you want to round them off to 5 and 3, I can change it to 5 and 3, and then leave the thickness as a 1/4 inch. Or if you want to add some thickness, so you can do a face cut to clean it up, you can do that as well.
Oh.
And then pick OK to accept it. So now your stock is defined right in here, and you can go to the Simulate tab, and if you click on Simulation Window, it actually displays a graphical simulation window for performing the material removal simulation. So we'll go back in here, and then we want to align the stock to the part. So we pick Align, and I can align it to the center in X, Y, and you'll now notice that the stock is aligned to the center of the part.
Okay.
In the next step, you would want to specify what material you're going to be working with. This can help you in establishing your feet and speeds as well. So if you're cutting aluminum or steel, or you can also add additional materials to the list. In this example, if you pick 6061, it also allows you to put a texture during simulation in here. As you click on Show Texture and go to the simulation window, it puts a texture of the material for simulation. It also helps you in establishing your feet and speeds.
All right.
Now, you see that I already have a library of tools loaded in here, but you can build your own library or use the default tool library that comes with the product. So you can specify tool types in here that you'd like to work with, specify the tool number. If you have an automatic tool changer, or if you're even doing manual tool change, you can assign tool numbers. You can set coolant types, feet and speeds. You can use the load from file option. And here you have the option to specify your stock tool material and help you in computation of feet and speeds. So as you're noticing here, I'm working my way from left to right as I work through each of these groups. So the next step is to establish the 0, which is called the program 0, or we call it the work 0. So you can pick where you want to put the 0, 0. I could choose set to stock, high as Z, either northwest, southwest, or one of these corners. I'm going to pick southwest. And if this needs to be output as a G54, you can select the work offset number and then pick generate.
Okay.
So you now 0, 0 is over here on the lower left corner of the stock. So as you take a look at the stock, you'll see that the 0, 0, 0 is being set over there.
Okay.
Would there be any questions so far?
No, so far it looks good.
Okay. All right. So now I'm taking some measurements in here. So this is about 0.276. So you could probably use a 1/4 inch end mill to cut that. And let's look at the diameter of the hole. It's a 118 diameter. Okay. And then this one over here is a 197. Okay. So we have holes of different sizes in here, right?
Yeah.
You have 165 diameter. So what you could do is you can program these holes. Would you like to do a spot drill and then a drill operation for these holes?
Yes, I'd like to do that for the 8 holes that are similar, and then see if I can do the other 3 holes with a 1/8 inch end mill.
Okay. So the first we want to do the smaller holes in here. So we can go to hole machining, and then we can select drilling.
Okay.
And we have an option to select holes on a flat area. So just pick the face right there.
Oh, okay.
Accept it. So you can see that it automatically identifies the holes on the 2 faces. And now I can apply a filter in here. So since you mentioned that you want to do these 2 holes, I can say select only holes that are up to a diameter of, let's say, 0.12. So it'll automatically drop these 2 out.
All right, that's useful.
So it's a filter for specifying a range for the diameter. And then you go to the tool section, and you can pick what tool would you like to use. In my library, I have an 1/8 inch, a 1/4 inch drill, but if I want to add additional tools, I can do that. So what tool would you like to use for drilling these 8 holes?
All right, so normally I'd spot drill with a center drill, and then I would just use an exact number 31. I think I used drill bit on it.
Okay. All right. So let's look at the drill sizes in here. I'm going to say number 31, right? So number 31 is 120?
Yeah.
Okay. So I'm going to create a drill. I'll call it number 31. So I can save this to my library in here. And does it have a 118 or a 120 tip angle? You can specify that as well.
Okay.
Right in here. And then you save this up as a new tool. it'll automatically assign an available number for the tool unless you want to use a different number. And then now over here, you can specify how deep you want it to cut. And for the spot drill, you can specify you want to go like 50 thousandths just to mark those whole locations.
Right. Okay.
And you can sort it in here, go by a minimum distance starting from the lower left corner. So it basically does a minimum distance sort, or I can do a directional sort as well. So now you can go into the simulation window. You can select the operation in here and hit play. That gives you a verification.
Okay. Interesting. All right.
And you can also assign colors during simulation in here. You can go to the properties and say you want to assign a color for simulation. So now when you run a verification in here, you'll see that each operations have a different color assigned to it.
Ah, okay.
So it just makes it easier to visualize it. So now we got through the drilling process. Now saving this part in Alibre, or you can do a save or save as, it automatically saves all of the CAM information that we put in here. So no additional file formats are being created. Now we want to repeat the same process for the other 3 holes. I'm going to do a copy and a paste, and then edit the operation. I can now either use flat areas, or I can just pick the face edges from the holes as well. By holding the shift key, you can do multi-select, and now you can specify a tool. You said you want to use an 1/8" tool for a spot drill?
Yeah.
So 197. So 197 is basically your drill now, drill size would be number 9.
Okay, yep.
Or if you want to add a number 9 drill, it will be 196, so I can add a new tool. Number 9 drill. So this is how I can build my library of tools in here.
And the tool library is global then? Or is
you can save it. Yeah, you save it. There's an option to, the tools that I'm creating in here are local to this part, but once I save it to a library, they're going to be global, so you can automatically load them on each program that you're working on. So there's the second drill operation. I can use a different color for it to identify in the simulation, and then there's the drill operation.
All right.
Okay, so now next step is basically you want to drill all the way through, right?
Yes.
Okay, so I can repeat the same operation in here, copy and paste it, and we have the drill number 31 in here.
Yeah.
Now I could have done this, minimize tool changes in here, so I could do this. First is I can call this spot drill.
Okay.
And then I could do a deep or through drill in here, and I can specify the depth by just picking the top face. I can go pick the bottom face. The depth is a 1/4 inch. I can say add the tool tip to the depth, so it automatically establishes the taper of the tool, whether it's a 118 or 120, and then makes a through hole. And if you want to do this as a deep drill or a break ship, you can select it from the menu here and generate it.
Okay.
So now let's go ahead and run a verification for it. So I'm going to go to the simulation window, and you'll see that it shows the deep drill process. The simulation mimics that behavior for you, and it's making it a through hole.
Now, if I wanted to change that to like a peck drill so it backs out after a while,
yep,
that's all?
Deep drill is basically a peck drill cycle in here.
Okay.
So it pecks and retracts based on the step increment that you put in, retracts to the clearance plane.
Okay, so it is.
It outputs a cycle, CAN cycle.
All right.
And now we have the spot drill for number 9. I can say number 9 holes, spot drill. So you can custom rename the tools, and this could be renamed to deep drill. So you have all of these controls in here. So you have the spot drill. You're going to run a verification for that. And then I'm going to repeat the same operation in here, make it a deep drill for number 9 holes. And I specify the same parameters like the total depth, a 1/4 inch. And then I can specify the peck increment, step increment, generate it. Then you can always apply different colors as you wish for simulation in here. And the beauty of our software is you can save all of the workflow into a knowledge base. So when you have a part that requires a similar set of operations, you can automatically have it, use the same operation workflow on other projects. Now here you can notice that I forgot to select add tool
Yes.
tip to drill depth, and in the simulation you can see that it's not making it a through hole. So the process of modifying this is very simple. Double click to edit, select the checkbox, generate it, and you can visually inspect it here by looking at the toolpath that it is going past. It computes the taper, and you can verify it in the simulation as well.
All right.
So now we got through the drilling hole making operations. The next step you'd want to do is machine the slot in here, right?
Yes.
And would you want to use like a 1/4 inch or a 3 1/4 inch end mill, because this is only about 276 wide?
Yeah, 1/4 inch would be fine.
Okay. So one of the ways we could program this is using a method called 2-axis. We have a slot machining operation. We could use that, or we could just do a engraving or a profiling operation in here. And all I got to do is pick these two edges. I can select the top edge or the bottom edge. I can pick these two edges right here. I can do one pass on running on each side. Pick a tool, a 1/4 inch end mill. Set the feeds and speeds, the clearance. In the cutting, I can choose climb or conventional or mix for cut direction. And here I'm going to choose determine the side to cut based on the 3D model, so it knows which side to cut. And in the cut levels, I can just pick this depth in here, and that's established as 59,000. If you want to do it in one or more passes, you can break this up into two passes if you'd like to. And then you can also control your lead in and lead out. Here I could say I wanted to extend out 50,000 past the workpiece, and you can control each of these parameters. So you have the most granular control that you need. And as you can see here, I did not pre-program the part. We're just doing it live during the demo with you. Right? So you can always go back in here, make those edits as you need it, and you can specify these parameters in here.
Okay.
And you can apply these entry and exits for each level.
So does it show the entry and exit on the simulate when I simulate it?
Absolutely. We can change it right in here as well. So here you're noticing that the entry and exit can be set, or you can even set it to, like, for example, none if you don't want it to. It'll just do a plunge right there. And if you go to simulation, you can actually, I'm going to pick a different color here. Just makes it easier to view it. So you can see now it's only not going past the model right there. But if I wanted to increase that, I can go back in here, and I'm going to say entry and exit, lines and arcs, keep it tangent to the geometry, lines and arcs, keep it tangent. So now it's extending out over here on both the sides. So now if I go ahead and run a verification in here, now if you wanted to further clear out the stock, you just wanted to increase the total length in here. I can change this from, make it like a 1/4 inch extending on both sides. So now it extends well clear of your material.
Okay. So it's automatically also calculating the feeds and speeds?
We actually use it from the tool, and we had the feeds and speeds defined based on the tool.
Okay.
So now we got through the profile. The final thing you want to do is cut the profile around the periphery of the part, and you can choose what scatter you want to use. So you want to see what's the smallest radius on the part. This is 197, so a 1/4 inch tool or even a 3/8 inch cutter might work well. So you can basically specify the areas that you'd like to cut in here. So there's a couple of ways to establish the boundaries in here. We can pick those face edges, so we can do a 2-axis profiling. I could even do a copy and a paste of this existing operation in here. Do a copy and a paste, and now I can edit this operation out. And now I need to just change the machining region. So I can basically select a bunch of face edges in here. As you see here, I'm holding the Shift key. In Libre, there is no chain command to automatically auto-chain the edges at this point in time.
Okay.
But I can still select it, or I can show you there's a few other ways how we can define, the boundary curve around the part. So in this particular step, I'm just using the manual process of selecting it right there. So I have those selected. Now I go to my tool. I can swap the tool out, set the feeds and speeds, set the clearance. In the cutting, I'm going to still use determine using 3D model. Now the geometry, what you picked is at the bottom of the part, and now you can pick the depth as, going from the top down to the bottom floor. It's a quarter inch, and you can say you want to break it down into 50 thousandths passes.
Right.
And now in this entry and exit, I can specify what type of entry and exit motions you'd like to apply. You could do a radial, apply these for each level. We can fit through arcs to the toolpath and generate it. So this will give you a profile cut, and it's picking the midpoint of the longest edge. Now, if you don't like where it's entering and leaving the material, you have a very nice way of controlling it. So I probably would prefer over here on this side or over on the other side. So what I'm going to do here is go to this tab called Regions, and in this Regions tab, we have the ability to create what is called flat area regions. And I can choose to ignore all the inner areas and then pick this face right here, accept it. It actually creates a single boundary curve around the part. So now I can modify the region. I can say pick a start point, and I can put the start point over here, wherever I need to. Or if I need to move it over closer to here or near the slot, I can leave it right there. So that's where my new start point is. So I have the start point defined. I'm going to edit this profile, remove all of this, select this predefined region, and clear this checkbox to use the midpoint of the longest side. So now you have the control on where you want to place your entry and exit. You also have the ability to have an overlap distance in here, where you can specify under entry and exit, where you can specify you want it to overlap by half an inch that goes past. So you don't leave any witness marks in finishing.
Right. Okay.
And now we are ready to run a verification. I'll just pick a color for the simulation in here. Select the operation, hit the play button, and there's your simulation. I remember you had asked me about bridges and tabs, right?
Yes.
So we have a very nice way to create bridges and tabs. There's a couple of ways we can do it. One is automatic bridges and tabs, where it automatically places those bridges and tabs, or you can even precisely control where you like the tabs to be placed in the part. So in this particular case, it probably makes more sense to have bridges and tabs like 2 on each side over here, right? Because there's not much material on these areas. So 2 on these 2 sides would help. So the way we would do it is, again, we go back to this predefined region that we created in here, and I can use automatic bridge points, or I can do manual bridge points, and this would allow me to pick bridge point locations. I can pick one over here. I can go back and do the same thing. I can pick one over here. So I have 2 bridge points defined. I can repeat the same over here for the other side as well. Create a manual bridge point. I can place one over here, and I can place another one right over here. So once I have the bridge points placed, if I need to adjust or move them, I can edit those bridge points and move them as well. So now I go back and edit the operation in here, and I can specify what type of bridge to be, triangular or rectangular, and all I got to do is give it a bridge height and a bridge length and generate the toolpath. Now you'll notice that it automatically creates those bridges in those specified locations. So if you run a simulation, you'll see that it automatically retracts in Z to account for the bridges.
All right.
So we have a total of 4 bridges.
Okay.
So now saving the part in Libre saves all of your CAM information with the part. You can estimate the time to see how long this might take to cut depending on the parameters that you put in. And finally, you want to do a post process, right-click and post. I have it set to take. It automatically grabs the name of the part, and your posted code appears in a text editor like a notepad. So you can see that calls out your drill cycle G81 for the spot drill, and then you have your G83 cycle for your deep drill operations, and then followed by your profile operations in here.
Okay, so now what happens, how well integrated is, if I change the CAD, how does it break the CAM, and how do I regenerate something, like if I change the size of a hole or something?
Well, in some cases, you'd have to go back and just reselect the geometry, repick the face, for example. You may have to reselect the tool, redefine the stock. The operations would still remain. If you just resize the sketch, then you're using a sketch as your containment or a region for machining, then you don't even have to repick it. If you add or drop or modify the sketch, then you'd have to go back and reselect it. So that's the beauty of being able to work inside an integrated system, is you don't have to re-export and start all over again. Also, this entire operations that you created, the workflow of operations, you can save them to a knowledge base.
Okay. So what does that do?
When you have parts that are similar to these, and you'd like to use a similar workflow or the same operation sequence, you load the knowledge base, and all you have to do is associate the areas that you'd like to drill or pocket or profile to the operation without having to go through the process of recreating all of it from the menu. So it's a big time saver. It's productivity improvement.
That's useful.
So those are also available right from our standard configuration. So saving basically saves all of the parameters like your tool, your feet and speeds, your clearance definition, your cutting depths, your sorting, all the information that you put in on a drill operation gets saved. Only the information that's not being saved is the actual geometry that's being machined.
Okay.
So you can apply them for different operations.
So is that where you save the global tool library then?
The tool library is, I would save it over here. Click on Save Tool Library. It'll ask you where do you want to save it. By default, it'll take you to the data folder. You can save it right here. And then when you load a library on the next project, it'll automatically assign the library to be loaded. Always load last library at startup. So it'll automatically load the last loaded library.
I see. Okay.
So that will eliminate the need for you to go back and load the library again. And you can use the same library. You can also add tools to update your library, and you can have your master tool library built.
Okay.
And there's also a very nice reporting tool. We call it as Shop Documentation. You can right-click and select Shop Documentation. So this creates a setup information sheet for you, which actually takes a screen capture of the part, also gives you information on the stock, the tools that you're using, the operations that you programmed, and it puts out this nice little report in HTML format, which you can actually, it comes in very handy for the operator in the shop floor, so he knows what tools to use, what to expect. And this is a concise and shorter format. We also have a lengthier format where you can grab a screen capture for each and every operation in the sequence.
All right.
Yeah, all of these are included right from our standard configuration.